Okay, geometry students, in this video we will be studying the relationship between arcs and chords. Now in the past we have looked at the relationship between... My pen is messing up, guys, hold on. It's not working right over here. Let me get my mouse out and fix this real quick. In the past, we have looked at the relationship between arcs and central angles, okay? So don't confuse the two, okay? Today we're studying the relationship between arcs and chords, okay? Arcs and chords. Your heading today is obviously arcs and chords. And be sure in the lesson numbers 10.4, be sure to include today's date, alright? Be sure and include today's date. Alright, let's continue on. Now, take really good notes. Let me throw a thought at you, okay? Take some really good notes on this if you would, please, okay? Take some good notes. First of all, I want you to draw a circle P, alright? So go ahead and draw a circle and call it circle P, alright? Then I want you to draw two chords. Make sure they're congruent, okay? Chord AB, chord DC. Now, I don't expect you to measure them and make sure they're perfectly congruent. I'm just saying make sure they look congruent, okay? In fact, I probably should have put a mark here and a mark here, alright? So go ahead and do that. I'll pause a second while you do that. Circle P with chords AB and DC, and make sure those two chords are congruent. Now continue on. Let's do this next, okay? Now notice now I have inserted four radii. A to P, D to P, C to P, and B to P. Four radii, okay? And when I did that, notice I naturally formed angles 1 and 2. So label those angles 1 and 2. Label these points A, B, or excuse me, we did that already. Be sure and label these two angles 1 and 2 and draw the radii, okay? Now after you've done that, here's what I want to show you. I want to show you that if you'll measure these two angles here, here, and here, now don't take time to do that, they will be congruent. They will be congruent. So what I'm trying to show you is this. Anytime you have congruent chords, like you might have a chord here and then a chord right here, if those two chords are congruent, then their central angles are going to be congruent. So in your notes, go ahead and mark this angle congruent to this angle. So if you had a protractor and measured it, you would see one's congruent to two. So what I'm trying to show you is this. If this central angle here is congruent to this central angle here, then that means this arc here has to be congruent to this arc here, okay? And so what I'm trying to show you here is whenever two chords are congruent, their arcs are also going to be congruent, okay? Because their central angles are congruent. Now, if you didn't get all that, it's okay, but I just want to kind of introduce this thought to you, okay? To jumpstart the class and get into things. Now, I want to say this real quick, so listen to this, please, okay? Hold on one second. My pen is still messing up, so I have to use the mouse over here and the pen over here. So, now I want to say one thing, okay? We've learned so far this entire time that chords are what make, central angles are what make arcs. Like a central angle here makes this arc, and that's true. But guys, other things can make arcs also. For example, like chords. I mean, if I have a chord and a circle right here, like this, does it not automatically make an arc with its endpoints right here? Sure it does. And so that's what we're going to be looking at today, relationships between arcs and chords. Alright? So with that in mind, let's go ahead and jump into this, okay? We're going to be looking at 4 theorems today. 4 theorems, okay? You're responsible for all 4 of these. Please take really good notes. I will go slow. I will explain them well, but please take good notes and listen, okay? So, here we go. Let's start with Theorem 10.5. Theorem 10.5. Copy this in your notes, please. You're responsible for this. Theorem 10.5 states, in the same circle, or in congruent circles, two minor arcs are congruent if and only showed you right back here a second ago, right here, okay? If the chords are congruent, which these two chords were congruent, then their arcs, well, I can't draw with a mouse very well, but then their arcs are congruent, okay? So copy this down, please. In the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Please copy that down. In the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Notice if and only if, and we'll talk about that in just a second, okay? Alright, here we go. In your notes, let's go ahead and draw a circle, please. You don't have to be perfect. Just draw an average circle like that. Alright, we'll call it circle A. And let's put a chord here. And try to draw a congruent chord. It's not very congruent. And try to draw, let's see, draw a chord here. Alright, and so let's put this A, B, C, D. Okay, please copy that down. Now, here's what the theorem is saying. Please take good notes. Please listen carefully. Alright? And guys, my pen is acting crazy, so we'll do the best we can to get this thing done. I'm not sure what's wrong with it. Let me pause the video and try to shut this thing off and try it again. Okay, students, I'm back. I've not fixed the problem, so we'll just have to deal with it. So here we go. So if arc AB is congruent to arc DC, okay? So here's my arc, and students, it's really hard to switch colors because when I take my pen over here, it just jumps over it like that. So we're gonna have to use one color today. So pay attention carefully. So if arc AB right here is congruent to arc DC right here, then go ahead and put the word then my chords are congruent. So chord CD is congruent to AB. Got it? Now look at that. Understand it. If arcs are congruent, then their chords are congruent. Got it? But hold it. Notice it's if and only if. So that means we can reverse this, okay? So, if the chords are congruent, then their arcs are congruent too. Let this sink in. I'm going to show you something else in just a second. But the main gist, or the only gist of this theorem is, if two chords are congruent, their minor arcs are congruent. And if two minor arcs are congruent, then the two chords are congruent. Period. Okay? So make sure you understand that. Alright, now, notice it says in the same circle or in congruent circles. It's very important that you see that. Okay? So let me show you what that means, although I'm sure you can figure it out. But what they're saying is this. If I have a circle here and a circle here, and I know they're congruent, let's say I've got a radius of 6 and a radius of 6. You can watch this or take notes. It's up to you. But I am going to go fast, so you'll need to go fast. If I have a radius of 6 and a radius of 6, then I know for sure the two circles are what? Congruent. Because we've learned in the past, two circles are congruent if their diameters or radii are congruent. So I have two congruent circles now. If I know this arc, this chord here has a length of 8, and I know this chord here has a length of 8, then the arc that goes from here to here is congruent to the arc that goes from here to here. Now, it's pretty much common sense, I know, but nonetheless, there it is, okay? And if I also said the arc in this circle is congruent to the arc in this circle, then I could know for sure that this chord here is congruent to this chord here. Now you can only go back and forth between two circles if the two circles are what? Congruent. So, got it, guys? If two chords are congruent, their arcs are congruent. Or if two arcs are congruent, their two chords are congruent. Okay? Alright, moving on. Theorem 10.6. Copy this down, please. If a diameter of a circle is perpendicular to any chord at all, then the diameter bisects the chord and its arc. That letters are so crammed up, it won't let me go past like this here. It's kind of freezing up. Alright, bisect means it cuts it in half, okay? Alright, so copy this down, please. You're responsible for this. If a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. Go ahead and copy this down. I'll give you guys just about a minute to do this, okay? If a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc, okay? Alright, let's go ahead and continue on. Now, let's go ahead and copy a circle here. Draw a circle, please, okay? Now I'm going to give this to you with letters and with numbers both, so you can take notes on both, or just one. That's up to you, okay? Now, I'm going to draw a chord right here. There's my chord, okay? Now I'm going to draw a diameter that is perpendicular. Like, here's a diameter here, okay? But that's not perpendicular to the chord, okay? So when you draw it, make sure it's perpendicular to the chord, okay? So there we go. So I want you to draw a chord and then a diameter, okay? Now off to the side I'm going to write if the diameter is perpendicular to a chord. So if, let's get some letters up here. A, B, C, D. So if AB is, first of all, a diameter. So if, I should have squeezed the word diameter in here, so write that in there, please. If diameter AB is perpendicular, sorry students, I think having this pen not working, it's got my mind all messed up. If diameter CD is perpendicular to AB, so write that down, please. If diameter CD is perpendicular to AB, then CD bisects AB, cuts it in half. Got it? So that means this segment here is congruent to this segment here, but it also bisects the chord. So this chord here, or excuse me, this arc here is congruent to this arc here. Okay? Alright, so let's look at it again real quick. If you have a diameter that is perpendicular to a chord, then this diameter right here cuts the chord in half, and it cuts the arc in half too. Okay, now let's look at it with numbers. If I'm going too fast, just have the supervising teacher pause the video, okay? Now, let's use some numbers here. So let's say I had 90 degrees written here, so you knew it's a right angle, alright? And I had 5 written right here for the length. From here to here is 5. And you knew this arc here, I'm not sure what to say, it has a measurement of 33 degrees, okay? Well guys, students, as soon as you know that this diameter is perpendicular to this chord, then you know if this segment here is 5, then this segment right here also has to be 5, okay? And if AC is 33, then you know arc CB also has to be 33, and all 33 degrees, and all that comes down to one fact: if your diameter is perpendicular to a chord. Got it? If your diameter is perpendicular to a chord, then the diameter bisects the chord and its arc both. Okay? Alright, moving on. If I'm going too fast, pause the video. Lesson or theorem 10.7. If chord AB is a perpendicular bisector of another chord, then AB is a diameter. Okay, copy this down, please. If chord AB is a perpendicular bisector of another chord, then AB is a diameter. Now while you're copying this down, just listen to me talk. Do you guys not see? This is pretty much, not exactly, but it's pretty much the converse of the last theorem. Up here we said if a diameter is perpendicular, then it bisects the chord. Now they're saying if a chord bisects a chord, then that chord is the diameter. Okay? So, that's pretty much the converse of each other. So up here, if a diameter, hold on guys, if a diameter of a circle is perpendicular to a chord, then it bisects the chord. Here we're saying if chord AB is a perpendicular bisector, then it is the diameter of the circle. And we'll talk about this in just a second. congruence. Alright, there we go. Here's chord AB. Okay, and here's we'll call this chord XY, okay? Now look, watch carefully. Mark this carefully. If chord AB is a perpendicular bisector, so we have to have a perpendicular symbol here, and AB is also a bisector. Now if AB is the bisector, that means AB is the one cutting something in half. So what is AB cutting in half? Well, I'm trying to get some different colored ink, guys. It's still not working. Let's use my mouse here. It's cutting XY in half, so this segment here is congruent to this segment here. So if AB is a perpendicular bisector of chord XY, then I know that AB is a diameter. So if AB is a perpendicular bisector of chord, it has to be a chord, okay guys? It has to be a chord XY, then AB is the what? Diameter. Got it? So up here, if we have a diameter that is perpendicular to a chord, then it bisects the chord in its arc, okay? Here, if a chord is a perpendicular bisector, then AB is a diameter, alright? Okay, let's go ahead and continue on here. Just a second, give you guys a couple extra seconds to copy this down, and then we'll go on to the next theorem. Okay, here we go. Okay, students, theorem 10.8, here we go. In the same circle, or in congruent circles, two chords are congruent if and only if, now this is interesting, listen guys, they are equidistant from the center. Now to me, that makes total sense, but I still want to explain this to you, okay? In the same circle, or in congruent circles, two chords are congruent if and only if they are equidistant from the center. Now first of all, notice the if and only if, okay? So because of the if and only if, you could also say if two chords are equidistant from the center, then they're congruent. Or you can say if two chords are congruent, then they're equidistant from the center. Got that? Let me say it again. Hopefully you're copying this down while I'm talking, okay? In the same circle or congruent circles, okay? Here we go. We can say two chords are congruent if they're equidistant from the center. Or we can say if two chords are equidistant from the center, then they're congruent. Okay? Now I'm going to give you a picture of this in just a second, but the reason I can say that is because it's if and only if. Alright? So here we go. Now watch what I do, please students. Take good notes, alright? Here's my wonderful, awesome me window. It'd probably work a little better. Alright, there we go. Alright, now, here's my circle. Alright? Alright, now, so if you hear a loud noise and the video goes dead, that means I've picked this thing up and thrown it out the window. Now, let's see, go ahead and draw two congruent chords. So I'm going to put one here and one right here. I mean, try to make them as congruent as possible, okay? Now, we've got to give them letters, okay, so we can talk about them. So let's do our usual A, B, C, D, okay? Alright, so there's my two chords. Now go ahead and put a center right here, alright? Now we're going to set this up two different ways, so please watch carefully. Also, now students, go ahead and draw the radius. Draw a radius here. Now listen, here's the thing. When we say a chord is equidistant from the center, we're talking about a perpendicular. it has to be a radius drawn. So this perpendicular. Would you please listen, students? I will explain why. If I tell you that a chord is a distance from the, if I tell you a chord is a certain distance from the center, does it mean this distance, this one, this one? How can a chord be a certain distance from a point? Well, by definition, we talked about this earlier in the year. By definition, when we say a line is a certain distance from a point, we're talking about the perpendicular line, okay? So go ahead and draw a perpendicular line right here. And then draw one also right here, okay? Like this. Got it? And let's call these 2 points E and F. Okay, so there we go. Now, let's continue on. Off to the side here, students, we're going to approach this 2 different ways, okay? So here we go. If CD is congruent to AB, okay? So we have a chord congruent to a chord. Then, watch this, they're equidistant, so we can say, let's give this circle a name, let's call it circle X. Then EX is congruent to FX. Do you see it, students? If the chords are congruent, then they're equidistant from the center. So we can say those lines going from the chord to the center are congruent. Okay? Now we can also turn that around. So would you please write it the other way? Let me change colors here to a different color of ink. And here we go. Hopefully the computer will not blow up. Alright, if. Now let's talk about this. If EX is congruent to FX, so this line here is congruent to this line here, then we can say that chord CD is congruent to chord AB. You see, students, as soon as you state that this line here is congruent to this line here, what are you saying? You're saying that these 2 chords are equidistant from the center. Okay, so if this chord and this chord is the same distance from the center, then those 2 chords are congruent. That's what this theorem is showing you, okay? So I think it would behoove us greatly to quickly take just 2 seconds and review. Got it? Okay, here we go. In the same circle, and if you didn't get all of that, I'll be back on that page in just a minute. In the same circle are congruent circles. 2 minor arcs are congruent if and only if they're corresponding chords are congruent. So, if chords are congruent, then their arcs are congruent. If arcs are congruent, then their chords are congruent. That's in the same circle or in congruent circles. Then we looked at if a diameter is perpendicular to a chord, the diameter bisects the chord and the arc. If a diameter is perpendicular to the chord, it cuts the chord in half and it cuts the arc in half, okay? Then we looked at this. If chord AB is perpendicular to another chord and it cuts it in half. So if a chord is perpendicular to another chord and it cuts it in half both, if a chord is perpendicular to a chord and it cuts it in half, then that chord is the diameter. The chord that's doing the bisecting is the diameter. Alright? And then lastly, we just looked at this. If 2 chords are equidistant from the center, those 2 chords are congruent. Or if 2 chords are congruent, then they're equidistant from the center. Alright, let's look at a problem here real quick, okay? Would you please copy this down in your notes? Actually, don't copy this down. Do not copy this down at all, okay? Instead, let's go ahead and draw. Just do it, instead of copying down these words, do what it says. So first of all, I want you to draw a circle A with a smaller concentric circle. So here we go. There's my first circle. Got it? And then here's my second circle right here. Alright, so, we're not asking for perfection. Just do the best you can on drawing those, okay? So, go ahead and put circle O right here for both of these circles, okay? So I'll pause a second while you do that. Draw a circle O with a smaller concentric circle, okay? Now, draw lines RS and UT so that each of these lines are secant to the larger circle and tangent to the smaller. So they have to intersect the bigger circle in two places, but they have to be let me slide this over here. But they have to be tangent to the smaller circle. Let me help you show you what I mean. This line right here, there we go. See that? That line right there is tangent to the smaller circle. If I can get my pen to work here. This line right here is tangent to the smaller circle right here, and it's secant to the bigger circle. It intersects the circle in two places. Alright, so let's do one more of these. Alright, let's draw another one of these lines here. So we'll draw it right here. There we go. And now, of course, I'm going to move it a little bit because it's supposed to be tangent to the little circle and secant to the bigger circle. So there we go. Students, that works just fine right there. Alright. So here is my point of tangency. Here. Or right here is my point of tangency. And then here's my 2 points where the line intersects the bigger circle. Okay, students, now let's continue on. Hopefully you understand what it's saying to do. Draw a line that intersects the outer bigger circle twice, and it intersects the inner smaller circle one time. And now, let's call these points of tangency A and B. Those are your points of tangency. Now, how do I know that segment OA, here's segment OA, is congruent to segment OB? Alright, how do I know that? Well, students, we know this for the very simple reason. Watch this carefully. Remember, we have, if this is a point of tangency, we learned that this line here has to be perpendicular to this line here, and this line here has to be perpendicular to this line here. Now I know they're both radii, and that's a very simple reason why AO is congruent to OB, but I'm trying to show you something more here, okay? So put these right angles in. What I'm saying to you is this. We know, we have to remember that whenever a line is tangent to a circle, it is automatically perpendicular to the line that is tangent. We learned that already in the past. So I'm just trying to show you here in review again is the concept that a lot of students forget, that the distance from a point to a line is the perpendicular line, and the distance from a point to a line is the perpendicular line, and these two lines are congruent, okay? Because they are obviously radii of the circle, okay? And also because they're coming off these lines at 90 degrees, okay? Alright, now let's take a look at page 502, numbers 1 through 8, okay? So turn your books to page 502, and let's look at numbers 1 through 8 for just a couple minutes, alright? Now, yes, always you may work ahead, but make sure you are getting the answers correct. Keep one eye up here on the screen as you work ahead. Alright, here we go. So I'm going to pause for a second. Everybody get your books open to page 502, and let's take a look at numbers 1 through 8. Page 502, numbers 1 through 8. And let's really reinforce and review what we've been doing so far. Alright, so here we go. If I'm going too fast, please pause the video. Alright, we're going to match A, B, C, D, A, B, C, and D with 1, 2, 3, and 4. Okay, so let's take a look at what we got here. Let's start off with letter or number 1. Now watch carefully. Let me change colors here to green so it shows up a little better. Now, in number 1 here, we have a chord. Well, guys, my pen's just not working. Look at my mouse at. We have a chord congruent to a chord. See this mark here? See this mark here? Now, whenever a chord is congruent to a chord, then we know the arcs are congruent. So this arc here is congruent to this arc here. So we're looking for arc AB congruent to arc BC. Here it is right here, letter C. arc AB is congruent to arc BC. So number one should be, I hope this is right, should be letter C. Yes, and what theorem is it? Theorem 10.5 says it's an if and only if two arcs are congruent, then their minor chords are congruent. If two chords are congruent, their minor arcs are congruent. If two minor arcs are congruent, then their two chords are congruent. Okay? Alright, moving on now to number two. We have here a diameter, and I know it's a diameter, students, okay? I know it's a diameter because it goes through the center of the circle. So I have a diameter that's perpendicular. Now we had a theorem that said if the diameter of a circle is perpendicular to a chord, then it bisects the chord and its arc. So I know this chord, this segment here, BC, is congruent to AC. How do I know that? We had a theorem that said if a diameter is perpendicular to a chord, then it bisects the chord, also bisects the arc. So arc, we'll call this E, arc AE is congruent to arc EB. But what they're looking at here is BC is congruent to AC. So let's cross off C. We've already used C. Do we see that anywhere? BC is congruent to AC. Yes, right here. BC is congruent to AC right here. So this should be letter A. Alright? Letter A. And it is theorem 10.6 that said if a diameter is perpendicular to a chord, then it bisects the chord and its arc. Alright? Let's go ahead and cross this one off right here. And let's continue on now. And now my pen has decided to work perfectly, so alright, moving on. Let's take a look at number 3. Okay, notice I have a chord here. Okay, please listen, students. Back in number 2. Yeah, now the pen's working great, good. Back in number 2. Well, it was, now it's not. I had a center. See it? So I knew this was a diameter because it went to the center. Got it? Look at number 3. I don't have the center of the circle, so I don't know this is a diameter. All that I know is I have a chord intersecting another chord. But how is it doing it? Well, it's perpendicular and it's bisecting it. So remember what we learned. We learned a theorem that said if a chord is bisecting another chord and it's perpendicular to it, then that chord that's doing the bisecting is the diameter. So because this chord here is perpendicular to AD and it's bisecting AD, then we know for sure that CB is a diameter. So CB is a diameter, and that's going to be letter D as in dog, alright? Letter D. If I can get this thing to work here. Alright, and it is theorem 10.7 that says if a chord is perpendicular to another chord and it bisects it, then that chord is the diameter. Theorem 10.7. Alright, well we know number 4 is going to be letter D, or excuse me, is going to be letter B. We know that, but let's look at it still nonetheless. Notice we have a chord. Got it? And a chord. And notice they're both equidistant from the center. Here's a perpendicular line. Here's a perpendicular line. And notice we have both those lines being marked congruent. Here's a mark here. Here's a mark here. So we had a theorem that said if two chords are equidistant from the center, they're congruent. We also had a theorem that said if two chords are congruent, then they're equidistant from the center, okay? But in this case here, we have two chords that are equidistant from the center, so we know those two chords are congruent. So CA is congruent to AB. AC is congruent to AB. So letter B for number 4. And it's theorem 10.8 that says what I just said. If two chords are equidistant from the center, then those two chords are congruent. Almost done, guys. Here we go. Alright, the directions say for 5 through 8 to use the diagram of circle P to explain why this statement is true. So let's start off with number 5, okay? Why is 5 true? AE is congruent to CD. I mean, how do I know that? They don't give me any measurements. How do I know that? Well, if you'll draw this chord right here, and if you'll draw this chord right here, count the spaces. Chord AE is 1, 2, 3, 4 units across. Now count this chord down here. 1, 2, 3, 4. Look at that. 4. Remember we learned that if two chords are congruent, then their minor arcs are congruent. So number 5, what's the explanation? I would put chords A, E, and C, D are what? Congruent. That's the explanation. Pretty simple. Alright, number 6. Number 6 we have AB is congruent to BC. So AB is congruent to BC. Now how do I know that? Well, you know that because here's circle, here's center P, correct? Draw the diameter. Go ahead and draw the diameter. Now, when you draw that diameter, you know it's perpendicular because we have a grid and we know all of these lines here run vertically and all of these lines here run horizontally. So we know because it's on a grid, we know for sure that we have a right angle right here. So, how do I know that AB is congruent to BC? Because I have a theorem that says if a diameter is perpendicular to a chord, then it bisects it. So I know this because diameter is perpendicular to AC. There you go. So because the diameter is perpendicular to AC, then I know it bisects it also. Okay, moving on to number 7. How do I know for sure that FG is not congruent to CD? Guys, they're not equidistant from the center. Look, here's FG is this far from the center, 1 unit. CD is 2 units from the center. CD is 1, 2 units from the center. So there's no way they're congruent because they're not equidistant from the center. So chords not equidistant from center. There we go, just like that. Okay. And sorry guys, messing up again. Okay, the chords are not equidistant from the center, thus they're not congruent. And then lastly, number 8, CAE. Now here's CAE. CAE is congruent to AED. Well, let's start first of all with the CAE. If you'll notice, CAE is a semicircle because it lies, the arc endpoints lie right on the endpoints of a diameter. Okay, so make note of that. Now let's take a look at arc AED. AED. Well, notice these endpoints also lie on the endpoints of a diameter. Well, students, we know the diameters are congruent, correct? So we know diameter AD has to be congruent to diameter CE. Okay, and here's the arc for CAE. They overlap a little bit, but it doesn't matter. So, how do I know these two arcs are congruent? You're probably saying common sense. I agree, but to give you a geometry reason or theorem reason, the two chords are congruent. We know that because they are diameters. Okay, so if this chord here is congruent to this chord here, then their two arcs, this arc here and this arc here, have to be congruent. Okay, I hope this video has been a help to you. If you have any questions, don't hesitate to call or email. Make sure you learn really,